What is up, everybody? Mr. Cozad here with another video lesson. Today's topic is a calculus lesson on finding the area between two curves, and today we're going to be using a calculator, okay, or technology. So it is really important for you to either have a calculator with you, or I'm going to show you a website that allows you to do what we're going to do as well. So here we go. So get a piece of paper, get a calculator out, and we'll roll through this. Okay. So obviously this is part 2 of this lesson series. A lot of what we're going to do is going to be dependent on you kind of knowing what we did in day 1, where we find the area between two curves. Okay. So basically the general thing that you're going to do here is we're going to break this down to a few steps. Okay, so step 1 when we do these problems is to graph both lines, or both functions is probably a better way to say that, okay, on the same graph. And then the next thing you're going to do is you're going to find the area that's enclosed by the functions. And then you're going to find the left and right bound. Those are the x values where the shaded region starts, and the x value where the shaded region stops. And then you are going to integrate, okay? And you're going to take the integral and remember, when we integrate this, goodness, I can't spell. Take the integral, and when we integrate this, we always do curve on top minus curve on bottom. So that is just kind of a real quick summary of the process, the steps that you take when you're finding the area between two curves. That's kind of what we covered in day 1, but we'll jump right into our problems for today. Okay, so here's the first problem that we're going to look at. So it says find the area enclosed by these two curves. Now obviously by looking at these two curves you can clearly tell they're a little bit more complicated than the types of curves that we had in day 1. So what I'm going to do is the first problem I'm going to show you how to do this on your graphing calculator. Okay, let's see here. Let's detach this, slide this down here so we can still see the functions. Okay, so on a graphing calculator like the TI-84, it's what we use in class, you go to y equals, and you're going to simply enter each one of those functions in for its own y value. So if x divided by the square root of x squared plus 1. So that's going to be my, I don't need that extra one there. So that's going to be my, yep, that's y1. And then for y2, let's do x to the 4th minus x. Minus x. Okay, x to the 4th minus x. Okay, so then you're going to go to your graph, and you're going to see the first function is graphed there for you. And then you're going to see the second function, x to the 4th minus x, come in there as well. So what you can see here on the bigger detached LCD screen, you can see that very clearly we've got a enclosed area here. So what I would do is I would definitely draw a sketch of this graph on my notes so that I can shade that in. Okay, so let me do that real quick. So draw a sketch of that in your notebook, and then remember that we're trying to find this little shaded region right here, the enclosed area. Now in order to do that, I need to actually find the coordinates of these points, where it starts over here and where it stops over here. Okay, so go back to your calculator, and the calculator can do that work for you. Let's see that. Where's that at? There it is. Okay, so the calculator can do a lot of this work for you. So first of all, I'm also just going to go to my calculate screen. So second, calc, and we're going to go down and select option 5, which is the intersection tool. So it's going to automatically default to a spot on your graph. Press enter. Then you want to look at the top to see if the curve changed from y1 to y2. Right now you're telling the calculator which two curves you want it to intersect, and then it asks you to guess. So one intersection point, it shouldn't be surprised, is 0, 0. So we would write that down as well. Okay, and what we are interested in is the x value on that. Let's do it again. So second calc, option 5. Go over to this intersection point. Notice that the first curve is y1. Press enter. Make sure that the second curve changed to y2. It's perfect. Press enter a third time and it'll spit out for us an intersection point. Now this one's a little ugly, but that's okay. So round this to 3 decimal places and write that down. Add that coordinate to your graph. So 1.181 and then 0.763 would be the coordinates that I write down. Okay, so you need to know, again, the general shape of the graph, which we got, and the coordinates of where the shaded region starts and where it stops. And we're specifically interested in the x coordinates of those points. Okay, now on your graphing calculator, you want to get out of the graphing menu. So go to second, quit. And now we're going to actually have the calculator do some work for us. So, and before we do that, let's look at the graph again and remember that we want to know which curve is on top and which curve is on bottom of the shaded region. So the curve that's on top is this blue one on my graph, which we got from the very first function, x over the square root of x squared plus 1. And the bottom curve is this x to the 4th minus x. It's important to remember what was on the top and what was on the bottom. Okay, so to get to the integration tool on your calculator, you're going to go to math. You're going to go down to option 9, okay, which is function integration. Hit 9. And if yours has the most updated software on it, you'll have a blank fill-in integral like this, okay, like I have. So lower bound. Remember, this lower bound is the x value where the enclosed region starts. That was 0. And then the upper bound is where the enclosed region ends. And again, remember, we're using the x values only. So we had the calculator do that work for us. 1.181. Now for the actual integration, remember we do curve on top minus curve on bottom. So the curve that was on top was the one that was x divided by the square root of x squared plus 1 so that's the curve on top, and then we're going to subtract the curve on the bottom. Now remember, on this piece, when you subtract the curve on the bottom, it's a really good idea to put that second curve in parentheses. So x to the 4th minus x. Oh, I forgot the minus. Minus x. Close that set of parentheses. And then you also need to, don't forget to come out here to the end and define which variable you're integrating in terms of. So we're integrating in terms of x. So let's scan it, make sure I typed it in right. The hardest part is typing it in right. From 0 to 1.181, that's correct. Top curve minus bottom curve with respect to x. So press enter, and it'll spit out for you a solution here. It'll spit out for you a solution. So there you go. You've got your first area of that enclosed region. Okay? Alright, now I'm going to actually show you how to do these problems using another tool that I think is really, really awesome as well. So here's a second problem that we're going to do. So it says find the area enclosed by the two curves. We have negative 1/2 x squared plus 6, and g of x is 2 to the x power. So what I'm going to have you do is I'm going to have you open a web browser. whether it's on a laptop. It's probably easiest on a laptop. I think you can do it on a phone or a tablet, but it's much easier on the laptop. And you're going to go to Desmos.com. Desmos.com. And when you get here, you're going to start graphing. Okay, so now on this tool, this one is a little bit easier. Let me minimize this for a minute so I can type these equations in. Actually, let's see how I can best set this up, because I want you to see what all I'm doing here. Okay, so here for this first blank here, you're going to type in the function f of x. So I'm going to do negative 0.5 x squared plus 6. And as you see, as you type this, it actually builds the graph immediately for you over here on the right. So then I need to type in the second equation, which is 2 to the x. And remember, to get exponents on a keypad, you're going to use the caret key. You're going to use the caret key. Okay, so clearly I can see that I've got my two curves here. The red curve is the quadratic, negative 0.5x squared plus 6. The blue curve is the exponential, 2 to the x. And very clearly you can see this overlapping shaded region here. Okay, it's created. Now what I love about Desmos is you can actually just click on the points and it'll show you the intersection points without having to go through and do much work on your own. Okay, so the x value that starts this overlapping shaded region is negative 3.437, and the x value that ends the enclosed area is 2. So those are important to remember for our upper and lower bounds. Now here's where Desmos is even cooler. We can actually have Desmos calculate the integral for us. So go to line 3, click in there, and then look at the bottom left of your screen and you see this keypad down here. Click that keypad. Then from this screen you're going to select functions, and then you're going to go over here to miscellaneous and go all the way to the bottom left, and that is your integral. So now what it's going to allow us to do is it's going to allow us to type in this integral. So let's see, I need the lower bound. So the lower bound was negative 437, I think it was. The upper bound is 2. And we're going to evaluate this integral. I like to put it all in parentheses. Curve on the top is negative 0.5 x squared plus 6. That's my curve on the top, minus the curve on the bottom, which is 2 to the x. Now remember, again, to get the exponent, use the caret key. Now a lot of you are going to forget to do this, but you need to also define which variable you're evaluating this for. So dx. And once you type that, you see that it actually spits out the integral for you here. So the area of this enclosed region would be 18.884 square units. I love Desmos. It's clean, it's easy to use, it's all right here on one screen. I love that. Okay, so there's one more. Here is a third problem. So find the area enclosed by the two curves. If you wanted to try your hand at this, you could pause the video now and go look at this on your own, but I'm going to go through this with you as well. So you have two choices. You can use the graphing calculator, or you can use Desmos. I'm, just for sake of ease, going to use Desmos. So clear out everything else. Okay, so curve 1, ooh, that's a fun curve, is e to the cosine x. That's a pretty cool looking curve. As you can see, it's already graphed for me right there. And then g of x is negative 4x plus x squared. It's negative 4x plus x squared. Okay, so have both functions graphed. Remember that I want to find the coordinates here of the intersection points. So that's negative 0.525. You might want to write these down, because you are still going to have to draw a sketch of this graph when you turn in your work. So draw a sketch of this graph as you see it. It's easy to draw a sketch of this graph because Desmos does such a great job drawing it for us. But draw a sketch of this graph and make sure that you label where the enclosed region starts and where it stops. So this is obviously the enclosed area. We'd shade that in, and we'd start at negative 0.525 and we'd go to 4.141. Okay, So go back to line 3 and remember to select your keypad, select functions, miscellaneous, and select your integral. So again, that was negative 0.525, and the upper bound was 4.141. And now we're going to type in top curve, which is the e to the cosine. So e to the cosine x minus the bottom curve, which is negative 4x plus x squared. And remember to type that in parentheses so you can distribute your negative sign. So like I said, subtracted in parentheses so it reminds you to distribute the negative sign. Make sure all your sets of parentheses match up, and then finally type which variable you're differentiating, and you get your solution. 15.804 is how we would round that. 15.804 square units would be the area of that section. So people, that's it. That is how you use technology to help you evaluate the area that you get between two curves. I hope this was helpful, and I'll see you next time.